Good afternoon, everyone. You are welcome to my YouTube channel. Today, we'll be looking at the part 1 of scalars and vectors, which has to do with the concept of scalars, the concept of vectors, how scalars and vectors are represented. Quantities in physics can either be classified into scalars or vectors. These classes of physical quantities are handled differently when used in numerical calculations. At the end of this topic, you should be able to explain the concept of scalars, the concept of vectors. You should also be able to explain how scalars and vectors are represented. Now let's start with the concept of scalars. Many measurable physical quantities we encounter in our study of physics today have only numerical values or numbers attached to them. Such quantities can only be described when their magnitude or sizes are known. Examples of such quantities are length, or you call it distance, speed, temperature, density, time, mass, velocity, energy. These quantities are called scalar quantities, and you should know them. You should have them at the tip of your fingers because you can be asked anytime. Give 2, 3, 4 examples of scalar quantities. You should know what to say. Now, what then are scalar quantities? Scalar quantities are quantities that have only magnitude but no direction. Now, we use 3 examples of scalar quantities to buttress my point on what scalar quantities are. The first example I will use is distance, which is called length. Now, if you say a distance of 60 kilometers, what does that mean? A distance of 60 kilometers can either be a straight line or a circular path, since no direction was specified. So since no direction was specified and we have a number here which is 60 kilometers, then this quantity distance is what? A scalar quantity. Also, speed. Let me use speed as another example. A speed of 50 kilometers can either be a straight line or a circular path, since no direction was also specified. So since no direction was specified, that means we can describe this quantity speed knowing only what? The magnitude or the numerical value. So since this quantity can be described knowing only the numerical value or the magnitude, then we can call this quantity a scalar quantity. Let us also use temperature, which is an example of a scalar quantity. A temperature of 100 degrees Celsius is a number, a subscale, since it has no directional property. It means that with this number, 100 degrees Celsius, you can describe the quantity temperature. So as a result, the quantity temperature is an example of what? A scalar quantity. Another thing we must know about scalars or scalar quantities is that scalars are added by ordinary algebraic method. I know you are wondering what I meant by that. It simply means that scalars are added the normal way you add numbers. Like if I say 2 plus 2, 4, 3 plus 3, 6, 1 plus 2, 3, just like that. That's how they add scalars. So let's take an example of scalar, which is volume, to explain what I mean by how scalars are added. So if you say addition of volume 5 centimeter cube and 10 centimeter cube, what will it give you? You agree with me that it will give you what? 15 centimeter cube. So this way I will say what? Scalars are added by ordinary algebraic methods. Just the normal way you add numbers. As you can see, we have just added 5 centimeter cube and what? 10 centimeter cube. When we added them, it gave us what? 15 centimeter cube. You will know that there's a difference between addition of scalars and addition of vectors in our subsequent videos. Is that clear? Now let's talk about the concept of vectors. Many other measurable physical quantities have magnitude or numerical value and direction as well. Such quantities are not completely described unless you know their magnitude and direction. Such quantities are called vector quantities. Now, examples of such quantities are displacement, velocity, acceleration, weight, force, momentum, and electric field. What then are vector quantities? Vector quantities are quantities that have both magnitude or numerical value and direction. Now we use two examples of vector quantities to buttress my point on what vector quantities are. I will use displacement and velocity to buttress my point. First, let's start with displacement. What is displacement? Displacement is distance measured in a specified direction. That means if there is distance in a specified direction, what you have is displacement. Now let's take this example to explain how displacement is a vector quantity. Now looking at this statement, a bird flies a distance of 100 kilometers in a northeasterly direction. This statement describes the vector quantity called displacement. How? If you observe very well, you discover that there's distance here, which is described by what? This number here, 100 kilometers, making it what? That's why what? Distance is a scalar quantity. But they don't just stop there. There's also what? Direction involved. And the direction is what? Northeasterly direction. So in a statement where you have distance, which is a scalar quantity, described by this magnitude or numerical value, and you also have direction, that statement describes what? A vector quantity called what? Displacement. And that's why I would say what? Displacement is what? Distance measured in a specified direction. So this statement describes the vector quantity called displacement. Let's use another vector quantity to explain what vector quantities are. Let's use velocity as another example. Velocity is speed in a specified direction. That means when you have speed attached to direction, what you have is what? Velocity. Now let's use this statement to describe what velocity is. This statement describes the vector quantity called velocity. How? It said a car travels due west. Due west stands for what? Direction. At what? 90 kilometers per hour. This number here that's attached to a unit called kilometer per hour stands for a scalar quantity called speed. Even though they did not write the speed here, that's why as a physics student, you must know the units of what? Physical what? Quantities. So when you see kilometer per hour attached to a number, that number describes a scalar quantity called what? Speed. So in a statement where you have this number that describes speed and you have direction in it, that statement automatically describes the vector quantity called velocity. But that's why I would say what? Velocity is what? Speed in a specified direction. That's why this statement is a vector quantity called velocity. Another thing you must know about vectors is that vectors are added by geometric methods. And the word geometry there means the relationship between lines and angles. That means there's direction involved in geometry. So the addition of vectors is a complex topic that will be treated in subsequent videos. But what you just know now is that vectors are added by geometric methods, unlike scalars, which are added by ordinary algebraic method. Now let's talk about vector representation, how vectors are represented. Since vectors has both magnitude and direction, we represent such a vector by a straight line carrying an arrow head. The line represents the magnitude of the vector, while the arrowhead represents the direction of the vector. So we say the length here is 5. We say the length here is 5 meters. It means that the magnitude of this vector is what? 5 meters. While this arrowhead tells you the direction, which is what? North direction. Now, this straight line with an arrowhead can also be represented this way. It can be in the form of what? That's the vector can also be represented in the form of what? A slant line with an arrowhead, or a horizontal line with an arrowhead. These are the 3 ways vectors can be represented: as a vertical line with an arrowhead, or a horizontal line with an arrowhead, or a slant line with an arrowhead. From all we've said so far, what are the likely ways you can be asked questions? Now I'll tell you. You can be asked to define scalar quantities. You can be asked to define vector quantities. You can be asked to give examples of scalar quantities and examples of vector quantities. You can also be asked to differentiate between scalars and vectors. If you are asked all these questions, what will you say? Now, for the definition of scalars, we say that what? Scalars are quantities that have only magnitude but no direction. While for the definition of vectors, you can simply say that what? Vectors are quantities that have both magnitude and direction. And if you are asked to give 2 or 3, 4 examples of scalars and vectors, you should know what to say. I gave you those examples earlier on. What if you are asked to differentiate between scalars and vectors? You simply say that what? Scalars are quantities that have only magnitude but no direction, while vectors are quantities that have both magnitude and direction. And what does that mean? Whenever you are asked to differentiate between 2 things, it simply means define the first thing, bring in a conjunction called while, then define the second thing. With this, we have come to the end of today's class. Please, if this video has been helpful, please like, share, subscribe, comment, and let us be partners in progress. Thank you and love you. Bye.